All right, let's go ahead and get started. Appreciate everybody showing up today. This is a very interesting and exciting topic that which has just come out probably about 2 weeks ago. So you're probably wondering, how did we get a presentation on this outside of Oracle so fast? Well, the way it happened is that Rio Data was actually part of the beta program for the 23C 23.4, excuse me, beta program that which gave us access to the vector data type in a limited release availability strategy. So back in February, I did this similar presentation at Rocky Mountain Oracle User Group on the fly. So I already had the presentation built and ready to go. So when they announced 23 AI on May 2nd, this enabled us to really formally talk about this now out in the public and create webinars and do more things with it. So I appreciate everybody showing up. If you've got, and we'll drive in here in just a second. A little bit of a housekeeping or webinar keeping things to do. If you got questions, feel free to ask the questions. Use the Q&A dialog box part of Zoom, and as I have breaks or as I pause there's 2 videos in this thing, I will answer your questions there. And if not, at the end, we will finish out answering all the questions that we didn't get to, and possibly open the chat up to actually talk about it a little bit more if we have time. There's about 46 slides in this whole thing. So we're going to be kind of moving a little fast, trying to keep within the hour to keep everybody on schedule for things. So if you got any questions, just feel free to ask them. I like interactive audiences. Just put them in the Q&A box and we'll answer them as we can throughout the webinar. If not, I'll take time later on tonight and download the questions and send you an email with the answers as well. So hopefully that's a little helpful for everybody. I'm Bobby Curtis. I'm actually the managing partner / one of the founders for Rio Data. Started the company in 2020, right prior to the global pandemic. What a great time to start a company, but hey, we did it. We live here in Atlanta. I live here in Atlanta. I'm an author, speaker. Some of you probably know about the Oracle Aces. I'm actually an Oracle Ace Pro, former Oracle Ace director as well, from quite a few years ago. So I guess I'm a glutton for punishment because I like doing webinars and I like writing books and I like doing blog posts and talking about the technology stuff. That's what makes this AI thing even more exciting across the board, because we're kind of seeing the evolution of our industry happening right before us. If you want to get a hold of me or you want to follow me on Twitter, the Twitter handles up there are for myself. DBA Solved is my moniker, which has been in place since 2012. Rio Data LLC is actually the company's Twitter handle if you want to follow us there. If you're interested in what I write, you can go check out both these blogs. They pretty much mirror each other, but they're the same things. And then if you want to get a hold of me, probably the fastest way to get a hold of me to get an answer is to send me an email at riodata.com. I used to give my Gmail account, but that's getting overflooded with just all kinds of junk. So feel free to send me an email, my work email address, and I'll answer questions as I see them come in, and I will get back with you. Along the bottom here, you see 4 books on the right-hand side, which is the books that I've had a hand in publishing or participated in getting out, which has been a very thought-provoking process to do with those things. And with that being said, there's 2 more books coming which I'm working on in parallel. One is on the topic we're talking about today, the AI vector data search, as well as the latest release of Oracle Golden Gate, which is 23 AI as well. So both of those books should be coming out. Hopefully, I'm hoping by August is what we're working on. So we'll see what happens. On the left-hand side here, you got Symposium 42. If you don't know what Symposium 42 is, Symposium 42 is actually a global network of speakers. Most of these speakers were actually former Oak Table members, and when Oak Table disbanded, they started a new organization, and there's a large group of us who actually like to speak, and so if you need a speaker for anything, you can go out to Symposium 42, and you can find speakers that will come in and do presentations for you on various topics. So that's me in a nutshell. Like I said, I'm not going to bore you to death with a lot of things around Rio Data, but just real quick, the service offerings that Rio Data offers, this is just the high level categories of everything that which we do, from managed services to data and cloud migrations using near zero downtime approaches to make sure you don't have any operational outages. Data engineering is where we're starting to get into the analytics, machine learning, and artificial intelligence of things, because you don't have clean data and data that can move on a regular basis, you're not going to have good AI solutions. Data modernization is just really more your visualization, dashboards, data warehousing, cybersecurity, things around that goes in it, and then also helping with license management. So that's really quick what Rio Data does in a nutshell. So if you're interested, feel free to reach out to us, and we'll connect with you and get some of these solutions put together. So now, as the topic presented earlier on the slide, on the beginning of the slide, is the 23 AI, Oracle 23 AI vector search, right? Vector data search. Now, there are some prerequisites to doing this. As I mentioned earlier, is that we were fortunate enough to have access to the limited availability releases of the vector search. And so what's listed here is no longer 23C, it's 23 AI. And then I've listed both limited releases or limited availability approaches at which we were privileged enough to work with. And in both of these approaches, they stack things on top of each other. So LA1 was really very limited on what it could do. LA2 had a lot more capability in terms of the SQL framework and what it could do in terms of packages and functions. So when they released it on May 2nd this year, it was very quickly out there on OCI. It was like, as soon as it was announced, literally it was out there. And then you could also get the on-premise versions of this database. You get the free version, like what they used to call the developer version. I can't remember, it was X something, XDB, or you can get the enterprise DB, the enterprise version of it as well to use this. But this vector data type is only in 23.4 and above, right? So that's the version of the database that which you have to have in order to use this particular vector search. Another requirement is Python 3.11 or 3.12, preferably 3.12, because the next line down, the Oracle DB or the Python-Oracle DB module has to be used within this framework in order to vectorize the data. And but that's just one approach. I'll show you a couple. The Python piece here, what they did during the limited release, they gave you access to a specific module that you had access to, that which is now 2.20 is actually publicly available. So if you're in Python, you can just download it with pip and run it. But that module has to have a particular feature in it for the vector data type, so it knows exactly what the data type is and how to vectorize it. And then using LangChain, if you follow the AI frameworks or the AI information for the last 6 months, LangChain is one of the big things that's out there. How do you do all this with Python and LangChain and build a chat bot and all this other stuff? LangChain is part of the process as well. And then lastly, you just got to be able to access your LLMs, right? Your large language models. So, and there's quite a few of them out there. ChatGPT, OpenAI's model. You got Cohere, that which Oracle's partnered with in OCI, to where you can build private large language models inside of OCI. You got Hugging Face, which provides a lot of open source large language models that you can download locally to your machine and build out. So there is a lot of flexibility when you start talking about vector databases and how do you start using vectors within your enterprise framework to actually develop these things. So, but in this case of using Oracle Vector Data Search, this is the prerequisites that which we dealt with, and the prerequisites that which are still the standard today and how to do things. All right, so let's talk about the what. First off, I want to introduce, you guys are going to see a lot of this robot guy here. It's kind of a play on AI, but it's we call him Eddie, EDDI. So if you want to say hi to Eddie, say hi to Eddie, but don't have to. So what is the what here, right? The what is really, we're talking about Oracle vectors, or how Oracle's implemented vectors inside of the Oracle database and how that's going to look and how it's going to change the way we do things within the database. All right. So the first thing we have to understand is vector databases, right? We've heard this term for at least the last 6 months. We've seen dozens, if not hundreds, of blog posts written on, oh, this is how you vectorize data using some sort of open source database, right? Some sort of open source vector database. And the popular ones that I've listed here is Pinecone, Weaveit, Chroma. That's the 3 big ones. Redis and Quadrant pretty much are like Amazon. You can run Quadrant in a Docker container on OCI, and all these other things. So you have a lot of options, right? You have a lot of options, but the vector database really is a specialized database that allows you to generate mathematical formulas for doing AI workloads, right? And a vector just allows you to do semantics on that data that you're looking at. So all these vector databases, the thing that they have in common is that they are outside of where your data resides, right? So how do you go from, hey, all my data is in an Oracle database somewhere, and I need to get it into Pinecone in order to vectorize it to be able to do my vector searches or to build a chatbot that can query this document or a chat feature or whatever else. You can basically just replicate it, right? You just pull the data over, but you're not paying attention, but you're not looking at it from the standpoint of security, and that's an inherent flaw in that model. Because when you're starting to go from, hey, I've got a secure database environment and I'm pulling into this vector database just so I can vectorize data to go to the next step. That's a security problem that somebody's going to eventually start pointing out. But the underlying theme here is that vector databases just allow you to do semantic searches across the board, right? So you have a lot of options. But Oracle's taken this approach of putting it into the database and making, we've heard the term converged databases for years, but the vector data type makes the Oracle database now a vector database, right? So it just basically allows you to run semantics. Vector search is exactly that. It's a search on the semantics of the data that it represents, right? So it gives you the ability to quickly query the information you're looking for based off of semantics and similarities versus precise matches, right? So where in the past we would go select star from table where column A equals some name, right? That's a precise match. I'm looking for this guy named Bobby, for example. Well, within a vector search, you're going to say fetch me the top 5 rows that match this criteria, and it's going to return it because it's using the vector data to mathematically find how close it is to what you're looking for and return that result set. And so that's how that really works. So we're moving away from this precise matching approach into a semantic approach by using vectors to do this thing. And at the same time, back to what I said in the last slide about security, is keeping it all within one environment. So you don't have to move data out of your database to do that. Okay, so I think I've already touched on this by accident, but vectors are just semantic representations of the unstructured data, right? So it's just a sequence of numbers. How big is a vector? We'll discuss that in a few minutes, but vectors are just sequence of numbers that say, hey, this is what describes this piece of data. Whether it's a JPEG, it could be a red truck inside of a picture would be turned into numbers that say, this is a red truck, basically. And so it's just highlights the important features and turns it all into numbers and stores it into a column that allows you to very quickly query that versus having to do a bunch of where and clauses or clauses to do a direct search, right? So when people start talking about vectors, it's just mathematical sequence of numbers called dimensions that allows you to find the features based off of the similarities. Okay, so semantic content of the vectors is all it is, right? Take the underlying words and turn them into numbers, but now you have to say, okay, when I do a SQL query, I have to turn what I'm looking for, the word or the name or the item or whatever I'm looking for into a vector. So you can vector compare to the vector that's stored in the database. So when you're writing an application, you have to say, okay, I'm looking for everything that's the color blue, right? That word blue has to be vectorized or turned into a vector, and then that vector is compared to the vector that's stored in the database. That's how the two comparisons work. But it's using the mathematical representations to make those comparisons and very quickly give it to you. So now instead of trying to convert a whole word and do a string search, we're now doing number searches across the board with these vectors. All right. So when we start looking at how do we build a vector, now that we have that concept of, hey, it's this mathematical thing, but how do we actually get a vector inside of the Oracle database or inside of any vector databases at that? You have to do what they call embedding. All right. So embedding is a large language model functionality that allows you to take a text string and convert it into numerical numbers that can be used in different languages, for example. So what you see here on the screen right now is online embedding models. This is the models that you could use against today against Cohere to embed data. So you could say, give me all the data that deals with table A and embed that whole column or that whole table and use Cohere to turn it into a mathematical representation of data and then store it into the database. That's what we call an online embedding model. On the right-hand column here, multilingual allows you to embed data. Let's say it's an English document, but you can embed data into multilingual embeddings, and then you can search that with French, German, Spanish, Korean, whatever. So depending on your use case and your clientele that you're working with, you would embed using one or two of these models and say, here you go. But whatever model you use to embed, you have to use that same model to convert the search term into a vector to be able to compare. So that's the caveat there. So if I used embed English version 3.0, which is a 1024 byte embedding, then I would have to use that same embedding model to actually do the search with, right? So that's online. One of the features for 23.4 is this concept of embedding the large language model inside of the database, right? So now in 23.4, you can take a open source model from Hugging Face and you can directly load it into the Oracle database, and then you can embed all your data based off of that model. But that rule that I just mentioned about that you have to use the same embedding model to do the search with is still there. But the difference is this is actually inside of the Oracle database. So now you will have a large language model inside the database that you can reference and continuously embed. And that gets around the whole concept of air gapping, right? Because some companies don't want to have access to the large language models publicly, because if you give your data to the public models, even if you build a custom model, they're using your data to kind of learn and build that language model to be even stronger. Where you want to keep your data in-house, you could take this approach, embed it in the database, and then just rebuild your model when you need to against that same framework. And you don't have to worry about anything getting out into the public. But you can pull those models down from Hugging Face, and we'll go through how that actually looks and works. All right, so the process to embed data into the database is that you got the object you want to embed, some piece of data, whether it's a text document, PDF, image, database columns, whatever you want to embed it. Then you would basically run it against the embedding model, which turns it into a vector embedding. And then it gets put into the database into a vector column. And then you would do your vector search against it. It returns the object that you wanted to retrieval and then gives you that content. So it's a simplified process here of looking at it, but it allows you to actually see how this process would actually work across the board when you want to take a piece of data, regardless of what it is, and store it inside the Oracle database or inside of any vector database, really, but particularly Oracle, and how you would retrieve it across the board. Okay, so that's a high view of what the vector data search really is. Okay, it's all the nice little fun little vectors, and this is what a vector is and stuff like that. So, but now we're going to look at the how. Right? the how. So the math beat behind this. I am not a math whiz, so I'm just going to cover the high level concepts and go on. If you want to get down to cosine and dot notations and those other things, I'd suggest you grab the Oracle documentation. It's got a lot of good information in there, and you can just read through it and understand how it really works. All right. So the first two models that which we have to use is the squared distance model, basically. Right. This reflects the distance between two different vectors, coordinates compared in straight lines. Right. So, hey, I've got two vector points. What's the distance between them? Right. Are they close to each other? Or are they further apart? The next model is the cosine similarity model. Really, what's the angle between the two vectors? Right. Like, is it a 30% degree? Is it a 50% degree? So on and so forth. It gives you where is it at in the framework? Right. And then you got dot notation. This is the one we're going to use when we look at a couple of videos here in a few minutes. But the similarity between the two vectors are viewed by multiplying the size of each vector by the cosine of their angle, right? So they're really taking the cosine and then multiplying it by itself to give you the distance or the dot notation of it. And then you got the Manhattan distance. This is really the sum of the distance between the two vectors, right? I got one at 0.5 and one at 0.7. What's the distance in terms of the calculated summations? And then the last model is what they call the Hamming distance. The distance is two vectors represented by numbers of coordinates where they differ, right? So think of it as ones and zeros, right? Everything's broken down ones and zeros, and then but how many distances are between those ones and zeros, right? To tell you the distance between the two. So that's the 5 models that you can use when you're inside the Oracle database and you want to compare a vector and understand how those vectors are in relation to each other. All right. So now, high level mathematics. Now, what's Oracle doing here? How is the how really happening with Oracle? Right? What are we doing? The whole thing about vector data search is the vector data type, is what it is. You can declare a vector data type in a couple of different ways. So when you create a table, right, and you go, hey, I got to create a new table. Is this going to be involved in a vector data search? Yes. So I got to put a vector column. How do I do this? The data type, this chart here shows the data types and how you can lay them out. So if you use the word vector with no parentheses after it, with nothing after it, you're going to get an arbitrary vector data column that which will hold anything, any size, any dimensions. It'll hold anything. It's the same as doing vector star dot star. Okay, so both of those are interchangeable when you're writing your create table statements. The next one down is vector with the number of dimensions and star. What this means is that how many specific number of dimensions do I want to use, right? So I can say 10, 20, 40, 1080, whatever, but I don't care about the size of the dimensions. The star just says, hey, give me any size. So they can be a 8 character size, 64 character size, 32 character size, whatever of the decimal formats. The next one down is the reverse of that, right? So I don't care how many dimensions I have, but I want them to be an int 8, a float 32, or a float 64, right? So these numbers will get very large, but you're not worried about how many dimensions of that you really have. You might have 1, you might have 50 or more. And then the last one is the vector where you want to define the number of dimensions and the number of dimension elements, right? So you're going to say, I want 50 dimensions of int 8, right? What that means is that when you vectorize something, you can have no more than 50 dimensions, so 50 numbers across horizontally, right? But they can only be a format of 8 bytes, right? So if you get 50 in a float 32 vector, it's not going to go in there. So you'll get all kinds of little nice little functional errors saying, hey, this is not going to work, and you'll pull your hair out. So until you get customized with how these things really work, how this vector stuff really works, the easiest approach is to use the top two, one of the top two, vector, vector, star, star. So that way you can kind of test it out, see how long a vector is going to be, and then how many dimensions you really need to define it. Another thing you got to understand that vectors cannot be null, right? So if you create a vector column and you're thinking, hey, I'm just going to leave it blank, can't do it. You have to put a value in that column. So Vectors cannot be null. And the example down here that I have is like 1.1, comma null, comma 2.2. You can't do that. You have to go 1.1, 2.2, 3.3. So they have to be sequential or whatever the number sequence is. So you can't just have a null passed in there, right? So that's just a nice little fun fact. Now, how do you create a table with this? You create a table like any other table, what you would do. Drop table if you wanted to, create table, add it in, and then what I've done here, I've done 7 different vector types. This is the combinations that you can do based off the previous table. And then you got a couple of different ones like dimension 3, float 32, dimension 2, 64s, dimension 1 of 8, dimension 1 of how many, doesn't matter what size, any dimensions at 32, and then any, right? Now, if you're in SQL Developer or VS Code and you do a describe on this table, you will not get this, what you see here. But if you're in SQL CL or in SQL Plus and you do a describe, you will get the actual data type listed out. In the previous 2, SQL Developer and VS Code, you would only get, hey, this is a vector data type. You won't get the actual the pieces across the board. All right. All right. So there's also a few functions that come along with this vector data type, vector data search. To-vector or vector. It constructs 4 vectors. In limited release 1, when we were playing with this, we were like, great, we can turn this vector, we can turn this data into a vector using SQL by using 2-vector. It doesn't work that way. I'll give you an example of that in a little bit, but it didn't work that way. This is a function where you can actually say, I want to take a string myself, let's say your name, and you can turn it into a vector at the SQL Plus prompt. You can't store it anywhere. It says, hey, it shows you what the vector is. But you could also say, hey, I want to take bracket 1.1, 2.2, 3.3 bracket and turn that into a vector. And then it will store that as a vector. But in terms of actually converting data to a vector, it doesn't do that per se. From vector or vector serial will actually tell you what a vector is. Like it'll take the vector and convert it backwards, like reverse engineering it basically to tell you what the vector is and how it looks and gives you the output. Vector norm is it's one of the Euclidean mathematical function of just normalizing the vector, giving you the square root of the sum of that vector where it's at. Vector dimension count will actually tell you the size of your dimensions. It will give you, so if you have a vector column, you say vector dimension count, open in the vector column name, it'll tell you the size of the vector. And then vector dimension format does the same thing. It tells you the character set or the format of if it's 8-bit, 32-bit, or 64-bit. And then vector distance is the one that you most likely will use the most, because vector distance will tell you by default the square root of the distance, right? But you can change that by saying different of those formulas. You can change it. But vector distance is what you're going to use the most when you start doing vector searches. Whether you do the vector search from SQL Plus or use in SQL, PL SQL, or Python, or Go, whatever else, vector distance is what you're going to use inside the database to do that search, right? So when you do a vector distance, when you use vector distance at the top here, the very top box is vector distance. You have to pass in 2 expressions and then the metric you want to use, all right? And so what I mean by that is that earlier I said you have to have a vector to compare to a vector. So expression 1 would be the vector that you submit to compare. Expression 2 is the vector that's in the column. And then the metric is actually the mathematical formula you want to use. All right, so that's the 3 things you have to provide to this procedure in order to do a vector search inside the database. And then by default, it does the Euclidean squared. So it's going to do that automatically. So that metric, you would say, hey, I want to do a dot notation. You would just change that metric to dot or cosine or Manhattan, and it would do that particular mathematical function for you. All right, so how do I create a vector? I know we've done all this infrastructure stuff. So how do I actually create it? On a new table, you would just create table, right? create table vector. And then the second example would be create table embedding. And then I'm giving it, hey, I want 384 dimensions of eight integers is the way that would work. Vector data type can be added to tables later as well. So if you got a table and you decide, hey, I want to add a vector onto this and I want to vectorize this table or vectorize some of this data, then you can do an alter table and just say alter table, add vector column, and give it the vector and give it the settings at which you want. That's how you would do that. All right, so if I want to just create my own vectors, you can. You can use this SQL approach and say create table, add a column for vectors, and then insert into that vector. And the format that what you see here is open bracket, comma, close bracket inside of single quotes. That's the format you have to use in order to create your own vector, right? So that's if you're a mathematical whiz and you want to create your own vector, have at it. That's how you do it. Then the online way of doing this is over with Python. Is that you would do it using this Python approach by logging in, connecting to the database, executing a SQL statement, set inputs. The set input pieces, set input size, this is the piece that I was telling you about at the beginning where you had to have that particular package of Python-OracleDB because you have to use this DB type vector in order to do the embedding. And then execute and commit. And that will create your vectors for you. So let's go with the Python approach and run through this very quickly. So I broke the Python code down into four simple steps to kind of show you how all this works. Is that you import the OracleDB package, you import, I'm going to do this online, so I'm using Cohere, and then we're going to use the OS, and then we're using LangChain, text loaders, and character splitters to actually break up a document to actually load into the database. Then I'm going to open that document. So it's just a cities.txt document. I'm going to read it, and then I'm going to split it by the characters, by the return character. I'm going to chunk it into every 35 rows. I'm going to have an overlap of 5, and then I'm going to take the length of the function, and the separator is false, right? And then I'm just going to say split the text of the cities into 35 chunks is all I'm doing. But the overlap piece is key because what you're going to do is tell the vectors that, hey, this is overlapping onto the previous one by five rows, and knowing back and forth how that works. Right, and then I want to use my API key for Cohere. I want to put that in place. Then we'll connect the Cohere. One thing to note: some of these large language models online will limit you. Cohere specifically will do this. Will limit you to 10 calls per minute. So if you've got a table or a file that has hundreds of thousands of rows, you're not going to be able to use the development one. You have to get a production one. A production one will allow you to do as many calls as you want per minute. So that's just the thing you got to be aware of. So if you just even with this small data set that I was working with, it was like 35 rows. I had to get a production one because as fast as I was testing, we couldn't do 10 calls per minute. We were doing more than that. So even in your testing, you may have to get a production one and vet that out and look at the use case there. And then lastly, 3.5, this is the intermediate step. I'm actually connecting to the database, the vector database online, and making the connection. So now I'm saying I've got my connection to Cohere, I've got my connection to the database, I'm good to go. Now let's start trying to vectorize some stuff. So at the very top here, I've set my ID value to 1 for counting purposes. Then I'm saying, okay, everything in the text, use the embedding model which is embedding English Lite v3. I'm going to embed it for classification. That has some things to do with it. And then as you get down to the bottom here where your cursors are set up at, the cursor's saying, hey, I'm going to use that DB type vector again to actually set the sizes. And then I'm going to insert into my vector table, and I'm going to use my text vector. And then the values that are coming in is that I have it circled, but it's highlighted where it says vec. That's what's going to get embedded into the table. Now, this is a quick video that will show you very quickly how this works. It's probably about, I think about 2 minutes. So let's see here. And what you're seeing here is that, okay, I just read through the text file. Now I'm connecting the Cohere, making the connection to the Oracle database. Now I've got the connection. Now I'm going to vectorize everything that was in that text file. And it takes about 30 seconds or so to finish that. But now keep in mind, we were doing this on a laptop and everything else, so it didn't go very fast. But for 35 rows, making online calls to Cohere embedding, and coming back for 30 seconds, 35 seconds is actually pretty decent for converting the text file which we had, right? And so now I have 53 rows in there that all got converted. And if you look at the numbers to the right here on the screen where it says array F and then the numbers, that's what was vectorized, right? So the data, Chattanooga is in Tennessee. Array F is the vectorization of that text string there. So, but if you also notice, it's not in sequential order, right? So it just went through all of it and said, let's vectorize all these sentences into things. So we're going to use those sentences to search for things in a few minutes. All right, so we created vectors. So now how do we start looking at these vectors and stuff like that? As I mentioned earlier, you have a vector that compared to a vector. So I cheated here a little bit by saying my text vector column ordered by vector distance is actually using a lookup. So instead of programmatically looking for this and vectorizing on the fly, I actually use a lookup table to do this. But that lookup table has to have the matching vector, right? So if it says Georgia or Alabama or Tennessee or Florida, New York, whatever, it has to have that word has to be vectorized in that lookup table in order to use it. And then the last line here, I'm saying fetch number of rows which I want. In this case, it was 3. All right, so now this is the SQL approach of doing that. What I just said is how we're going to look up everything in that table that we're looking for. So if you look at this, it's like return the first 5 rows of Georgia, first 3 rows that are dogs, first 3 rows that are Florida, and I think the last one's really I'm changing it to the city in Florida that begins with a T. So if you look at, just watch this for about a minute. And so right here, I'm just checking the table just to confirm that we have vectors, right? So text to vec is on the right-hand side there. And the text that we're going to return in this vector search is actually the text that's in that column. All right, and then I'm going to say what's in the vector lookup table, just so I can kind of, like I said, I'm kind of skirting the system here, but I'm looking for, I'm going to use the vectors that are in that column. Now give me the first 5 rows. And you see I've got the first 5 rows that begin with A in Georgia. Give me the first 3 rows of dogs, right? And what it's keying off of here is the word dog. Is what it's doing. In this one, it's first 3 rows for Florida, right? But now if you look, if I was paused here, notice New York is in there, right? And Georgia's in there. Because I said give you the first 4 rows, there's only 2 cities. So there's a little bit of a gap there you just got to be aware of. Because when you say fetch first number of rows, it's going to give you everything in that 4 criteria. And this last one, it says fetch for the first row that has Tampa in it, or T in Florida. So that's really how the vector searches is, because I'm using the vectors that are stored in the table with the vectors that are stored in the lookup table and making the comparison that way. And that's very fast, right? And so as we were doing this, and as I was doing this, I was testing, I was playing around with this thing. There's no indexes on any of these tables. These 43 rows were selected like a full table scan, full access, everything, less than a millisecond across the board. Barely used anything, and that's without indexes. We will be doing another webinar later on in June about vector indexes, because that's the other part of this, vector indexes, because as you get millions of rows put into a table, you got to be able to index those vectors and search those very quickly. Those have some really cool things you can do with vector indexes, because it also affects memory share and how those things work. So, but before we can jump into those, basic understanding of how it works is really key. So, but just for a straight up full table scan run, less than a millisecond is unbelievable for how fast it is, right? Because we're doing mathematical searches versus full text searches. So earlier I mentioned, hey, let's embed an LLM into, because I want to do this air gap approach. I don't want to have data going out to the public LLM. So how can I do that internally and do that inside the database without having to build a separate vector database? And that's how we just embed the LLM into the Oracle database. So the way you do that is with ONNX files, open neural network exchange files. And those files are specifically formatted and designed for machine learning models. So you can build a machine learning model, turn it into an ONNX model, embed it into the Oracle database if you wanted to, and use that for your embedding and exchanges and stuff like that. So it's a very popular, I don't want to necessarily say open source, but it's what everybody's using to actually build out the frameworks, right? And so in order to do this, you have to have 3.12 of Python. That's the minimum as you can do this with. You have to set your Oracle home, set your Python home, or use Python within the Oracle binaries. And then you're going to set that Oracle home with Python bin into your pathway. So that way you can very quickly use it. And then you're going to make a directory called ONNX, just so you keep your logical stuff nice and neat. And then you're going to use the omlutils.zip file, that which, from all indications, comes bundled with the Oracle database, right? The zip file is supposed to be with the binaries. You take this, you unzip it into a directory that you want to use, and then you're going to use those utilities to actually embed the stuff into the database, right? And then you're going to use inside that zip file, there's requirements.txt file, that which is going to install the additional things that you need for this to work. And then the OML utils will file will actually be installed as well. So you have to use those are all the pieces that have to be done for that to be put in place. And then once you have those in place, then you would use Python, just add an interactive prompt, and you would say import embedding model config, and then give it the model, the string sentence transformer you want to use, and the model you want to use. This all mini LM L6v2 is an open source model that you can get from Hugging Face, and it just loads it right on up. And then you can say export file out to the directory, and then you have an ONNX file that you can turn around and load. Now, once you have it loaded, then you can start checking to see where it's at. So in this case here, we've got a model named doc model, and there's a couple of new views. The big ones to really worry about in terms of embedding models is data_models, where you can do DBA, user, or all, right? The wildcard there. So, but this table or this view will tell you who's the owner of the model, who's the model name, what's the function for it, what algorithm it is, native, when it was created. So that way you can very quickly identify if you have to build a new model, embed a new model, update the model, whatever else. But just because this is owned by the vector the owner vector, as long as I have permissions to do a view model, I believe it's view model, then you can use that model from anybody, right? So whoever's going to create the vector has to have permissions onto that model in order to use it. And I believe it's view model that has to have that permission, right? And then once we have it embedded, once that model's and put it in place, earlier I said the toVector function doesn't do what we think it does. Well, it's slightly changed inside of limited release 2, and for the production release, it does do what we want it to do in terms of converting data into a vector. However, you have to use an additional function with it. You have to use vector_embedding, that which will allow you to say, okay, vector embedding. So I'm telling the database to embed this vector, but I'm going to use the model that which I have inside the Oracle database, that's vector deck model, using URL. The URL in this case here is just a column name, right? It's not because we're building out something, but so it could be first name, city, state, whatever, as data, right? That's the keywords. So that column as data has to be there in order to say, okay, so I'm going to take this column of data, I'm going to embed it into the database, and I'm going to vectorize it. That's how that reads out. And then it goes puts it into that table, into that vector column that you've added to it. Then when you want to update that column across the board, remember, you can't put nulls in it, right? So what I mean by null is the vector itself cannot have a null in it. But the column can be blank, because when you add the column, there's nothing there yet. So you have to go and update the column, and this is how you would do it in SQL. You take the same select statement, or you take the select statement and say, hey, I've got this embedding model I want to use. and set it as your set clause, and then say and run, and then it will go through and embed and architect all of the columns or all the rows into that column for you, right? So this opens up a lot of possibilities. Vector search is going to drive growth in a lot of different places. You know, Apple just announced that it's got AI chips for inferences. We've heard NVIDIA for the last 6 months is the Wall Street darling because of all that stuff. Oracle's taking the approach of, at a logical layer, at your data layer, we can turn it all into vectors, increase searches, increase chatbot capability to give customer real-time solutions. And so this is going to impact everything and where everything's going, and how you look at your data warehousing, how you look at using chatbots, and how do you really gauge scaling within the environments, right? And so one of the big things that everybody's talking about today, or last 6 months, has been RAG, retrieval augmented generation, right? Generative AI is a general term. This gets down to a little bit more in depth of what this is. When you start looking at large language models and start training models and then laying models out, RAG is really the easiest way to give your enterprise data and LLMs together to get the results that you want, and as natural language processing advances, right? So you might have a bunch of things inside of your database that which are proprietary to you. You don't want it going against a public LLM. You can bring the LLMs to you and you can generate your embeddings. And that's what the vector data search is for. All these embeddings is actually to enable RAG across the board, right? So to enable RAG, this is really how this works. Enterprise database, you're retrieving your documents, you're converting it with an embedding model, and you're storing it in the vector database. In this case, the Oracle database with the vector data column. And then you're going to query, the applications query it by taking the search function that you're looking for, querying it or converting it into an embedding model, checking against the database, going against the LLM to get the results that you want married up with your data, and then returns it back to the application. So it gives you a lot of flexibility to enhance applications, interactions with end users across the board, whether it's in HR or sales or anything. Even in IT, you can use a chatbot to diagnose different things inside of your environment. Right. So some common use cases that you're probably going to start hearing about on a little bit more frequent basis is search. This is a known use case, right? Improved search. All of our search engines, Bing, Google, Yahoo, all these other guys do search basically through vectors, embedding and stuff. They just never publicized it, but that's what they're really doing. And so now this is becoming more commonplace and more natural for the everyday user in IT and databases to use. Natural language processing and search, again, semantic search is happening, but hey, write me a query for finding how many people had orders in the month of July. That can be done now because the AI will go look at your database, generate the query for you, and give you the result sets. That's out there as well nowadays. Recommendation systems. Hey, this person's bought 5 of these in the last month. Maybe he'll want to buy another 2 more next week, right? And we'll sell to him for something. Biometric and anomaly detection. This is going to be big in healthcare because of, think of cancer diagnosis, scanning, diagnosis of blood samples and stuff like that. There's going to be a lot of things that come out of the healthcare industry with this. Drug discovery is going to speed up the time for patent building and all this other stuff into the drug industries. Similarity searches as well. Personal digital assistants. How many of you guys have an Android or an iPhone with you? You have a digital assistant right now. This is going to give them even more power to actually identify what's going on inside your corporation and give you result sets based off of whisper technology and stuff like that, being able to very quickly gauge what AIs can actually get done. So it's all great and wonderful. The Oracle database is going to give us a lot of flexibility because it's the enterprise standard that we've all used for decades. Now they're taking it a next step further in terms of performance and speed and functionality within the AI spectrum. across the board. So now you got vector database data types need to be secure, right? By using the vector data type inside the Oracle database, you keep it secure versus taking your data out of your database, putting it into one of those open source vector databases, and then pulling it back in. So everything is secure across the board. And this is going to only evolve and become more and more popular because Postgres is doing this now with PG Vector. There's MySQL's done it as well with data vector storage. And then you've got, Microsoft has yet to announce what they're going to do to compete with this vector type. So everybody's so the open source vector databases will start dwindling, I believe, because all the industry standard databases are going to start picking up how to do this vector data type and plug in. And Oracle's the first one really to the market with it. Organizations should evaluate data that they want to vector. Not everything has to be vectorized. All right. So you can't just go full bore into the vector data type and say, hey, this is going to solve every problem. Organizations have to be very selective on what they want to vector and what they want to give out. Right. So if you do online embedding, you're going against a public LLM. So you got to be very careful with what you tell that LLM in terms of what you're trying to turn around and embed and then use and RAG, and because they're going to take that data and use it for fine tuning of their environment. So public LLMs are not bad; they're useful. It's just that you got to be cautious on how that's going to be used down the road with your information. So consider building private LLMs, and that's what the embedding functionality of this is that you can take a publicly accessible LLM, take a downloaded version of it, embed it with an Onyx file into the database, and then it keeps that model secure. You can embed what you want to embed very quickly through SQL, and then use it in your applications however you want to use it. And then every 3-6 months, if you have to refresh that model, it's all there stored in your database in your housing. So that's going to change fundamentally how us as DBAs are going to look at work and go, performance-wise, how does this work? How does this model have to be refreshed and these type of things? So equate it to more of a infrastructure change to taking your data to the LLMs and providing more information to the end user, right? So I didn't see any questions pop up, surprisingly, but if there's any questions, feel free to throw them in the chat windows or whatever else. A little humor here. I'm not an AI, but I can answer some questions if need be. But if not, I appreciate everybody coming, but stay tuned to announcements that we've got coming, because we're going to be pushing out next month. We're going to be working on the Oracle Golden Gate 23 AI, right? So now that we got the AI vector data type, what does this mean for data integration, data replication type of things, and how you move data with the industry's best replication tool for replication, right? And data integration. That's Golden Gate. So we're going to be talking about that on June 13th. And then June 27th, if everything works out tentatively, it might get pushed to July, but right now we're targeting the 27th. But we're going to come back to this topic and talk about vector indexes, right? Because we just talked about all the vector data type, how it works, all these other things, how fast it really is. But when you have millions of rows, how do you vectorize that, index that, and then have that perform correctly? Because there is a new functionality called vector indexes as a vector pool size that goes into the SGA as well, that we'll talk about. So hopefully you guys can join us with that. And then I'll stay right here for a minute. I just saw somebody make not a comment. They just made a comment. Appreciate it. Thank you. And so if there's anything else, we would love to talk to all of you if you're interested in learning more about this and actually looking at how to get there. And you're right, because you got to go from 19C, 21C to 23C now, right? 23C will be the long-term release. I was told yesterday that 21C has a 1-year life cycle. So if you're on 19, you're still good. But if you're going to 21, you may want to consider going to 23. So we would be willing to talk to you about that. If you want to give us a call or shoot us an email about all these things, we can be reached at all these QR codes and channels that which we've posted all throughout the presentation. So with that, there's really no questions, but I appreciate everybody coming. Hopefully I gave everybody back some time. I'm actually about 1 minute over. So thank you for coming, and hopefully we'll see you next month. Thanks.